Alright, so today we're just going to be reviewing. So actually I'm going to be giving you a practice worksheet to do. It's attached to the Google Classroom assignment, and I'm going to ask you to do the evens. So I'll do the odds, and I think that'll be fair. Today is the 28th, and this is section 6.2. We're talking about amplitude, period, and phase shift. Alright, and we'll just start right up. First problem is we're looking for the amplitude, period, and phase shift. First problem looks like this. -2 times the sine of theta. Amplitude, period, and phase shift. Okay, amplitude would be the absolute value of -2. The period, there's nothing in front of theta, so it's the normal period divided by 1. And the phase shift, we're not adding or subtracting, so there's no phase shift. Number 3, it says y is equal to -3 times the sine of 4 theta. There's no plus or minus, so technically it's by itself. Now the amplitude would be the absolute value of -3, which is 3. Period would be the normal period of sine divided by 4. Let me see, no, it's not 120, it's 90 degrees. Come on, Brad, or Mr. Ottino. The phase shift, well, there's no plus or minus, so we say that the phase shift is none. Okay, and then number 5, it says y is equal to 2.5 times the cosine of theta plus 180 degrees. We don't have to factor anything out, there's no number in front. So the amplitude would be 2.5. The period would be the normal period divided by the number in front. And then the phase shift would be 180 degrees to the left. For phase shift, you always have to tell me the number and the direction. Let's move on to number 7. Number 7, it's asking you to write an equation for sine, and this is the way we set it up. So for number 7, it's telling us that the amplitude is 0.75, the period is 360, and the phase shift is 30. Okay, so amplitude is going to go right here. We could put 0.75 or negative, it doesn't matter. The phase shift is 30 degrees. We talked about if there's no sine, it automatically means it goes to the right. The period is 360, so the way we get the period is we take that k value, the normal period, divided by k, and that's going to be the period that they tell us, which is 360. Well, the normal period is 360, so 360 divided by what is 360? 1, right? So we could just leave that. That's what it would be. K is equal to 1. I mean, we could cross multiply here, but I'm sure you guys are smart enough to know that 360 divided by 1 is 360. All right, let's move on to number 9. Number 9, it says we're going to be doing the same thing, but we want a cosine. And number 9, it says the amplitude is 3.75, period is 90 degrees, and the phase shift is 4 degrees. Again, if there's no sine, it automatically goes to the right. So the amplitude is 3.75, phase shift is 4 to the right. And in order to figure out what k is, we take our normal divided by k, and that gives us 90 degrees. Well, the normal period of cosine is 360. So 360 divided by what is 90? I know it's 4, but you can multiply both sides by k. And divide by 90. We get k is equal to 4. So that would be the answer. We have a couple graphs to work on, and then we'll be done. So a short lesson today. Number 11, it says y is equal to 0.5 times the sine of x. Now, remember what we said, that when we're talking degrees, usually we're going to use theta. When we are in radians, usually we use x. But this book, it's a little bit confusing because they use x and then they have degrees in the same thing. So just make sure you could go back and forth between degrees and radians. So for this, I'll use degrees, and some of the upcoming lessons will be using more radians, but you could use degrees for this homework and the notes here. So we always start by talking about what should it look like based on the amplitude, period, and phase shift. Amplitude's 0.5. Period, there's no number in front of x, so it's just the normal over 1. And the phase shift, there's no plus or minus, so we say it's 0 or none. Let's set it up. The highest it's going to go is 0.5. The lowest it'll go is negative 0.5. 2, 3, 4. 1, 2, 3, 4. And we can make a table. And, in our calculator, we're going to type in 0.5 times the sine of A. And if you start at negative 360 and you type it in, let's see here, negative 360, store it for A. 0.5 times the sine of the variable A is 0. And because the period is 360 degrees later, it'll be 0. 360 degrees later, it'll be 0. At negative 270, store that. Calculators tell me it's 1/2. So 360 degrees later, it'll be 1/2. And we start to see the shape. Now I'm going to guess that it drops down to 0.5, so the graph's going to look something like this. And if you don't believe me, you can plug in negative 90, but after a while, there's no electric problems. If you're expecting a wave and you connect the dots, it should look like a wave. Negative 90, you should get negative 0.5. I'll just double check. And that's exactly what you get. All right, so you could pick all these points if you want. You could pick every single one of these points if that makes you comfortable, or you could use the amplitude, period, and phase shift to help you draw the graph. So for homework, what I would like you to do, on practice 6.2, I just did the odds. I would like you to please do the evens. All right, that's it for today. Thank you very much. Have a nice day.